This presentation is about Tri-µ-carbonyl-bis tricarbonyliron and its neutral and ionic compounds. First, let's identify the ligands. This both helps in the name and in identifying them for later use in electron count. There are 3 bridging carbonyls, and then there are 3 carbonyls in each of the 2 irons, so bis. It has no charge, so we add the 0, and we end up with Tri-µ-carbonyl-bis tricarbonyliron 0. Now let's start counting electrons. Since there's 2 irons, we only count for 1 since they are the same. The core electron configuration for iron is argon 4s2 3d6. All electrons on the s and d orbital count towards the total valence electrons. So we count the 2 electrons on the s orbital and the 6 electrons on the d orbital. So there are 8 electrons from the iron. Since the metal is neutral, there is no charge, and we count all 8 electrons. Carbonyls contribute 2 electrons each, and since there are 3, then it contributes 6 electrons. Mu carbonyls are the bridging carbonyls. They contribute 2 electrons, but since the electron pair of a bridging ligand donates 1 electron to each of the bridged metal atoms, then we only count 1. Since there is 3, then it contributes 3 electrons. Odd electron metals attain 18 valence electrons through formation of metal-metal bonds or through reduction. So the bond between the iron metals, the MM bond, contributes 1 electron to the total electron count of a single metal atom. The ionic model is the same as the covalent, since both carbonyls and the bridging carbonyls have a formal charge of 0 and contribute the same amount of electrons as in the neutral model, which are 2 each. And the MM bond still contributes 1 electron to the total electron count of a single metal. And so, just like other metal carbonyls, both the ionic and the neutral model have 18 electrons.